going to talk about graphs of exponential decay, section 7.2. Now, if you remember from our lesson 2 lessons ago, we talked about exponential growth. So you should remember that an exponential function is any function of the form b to the x, where the b, the base, is a constant and your variable is in the exponent. Now, if it was an exponential growth function, then that means that your b had to be greater than 1. And as x got bigger, your y values got bigger. Well, today we're going to talk about exponential decay. And it's going to mean as x gets bigger, y gets smaller. So your graph's going to look a little bit different, same basic shape, but flip around the other way. We'll look at that in just a minute. For that to happen, b still is going to be positive. It's always positive. But it has to be less than 1. That's going to create exponential decay. Decay meaning it's getting smaller. So let's graph the one I have up here. Y equals 1/2 to the x power. Start by graphing. We're going to find 3 points, and I want you to find these same 3 points on all of your graphs today. So we're going to do -1, 0, and 1. So when x is -1, y will be 1/2 to the -1 power. Well, remember, the negative in the exponent means that it creates a reciprocal. So the reciprocal of 1/2 is 2. So I have the point 1, 2 on my graph. Next, we'll do the point when x equals 0. So we have 1/2 to the 0 power. Well, everything to the 0 power is always 1. So I have the point 0, 1 on my graph. Then we'll look at the point x equals 1. So I have 1/2 to the 1 power. Well, anything to the 1 power is itself, so that's 1/2. So let's plot our 3 points. Don't forget to label your x and y axis. I've got the point -1, 2. I've got the point 0, 1. I've got the point 1, 1/2. You can see there's the basic shape of your graph. Now let's check it out. Is that what it looks like when you graph it on your calculator? So, get your calculator out. Hit the y equals button. When you go to y1, don't forget your parentheses. You have parentheses 1 divided by 2 raised to the x power. Let's see, when you put it in your calculator, you have to use the little caret button. So raised to the x power. When you look at it, when you check it, it should look something like that. Now, if you remember, we did the little trace deal. If you do a trace, and this time you run the arrows on your cursor to the right, you should see that as x gets larger and larger, check your x and y coordinates, y is going to be getting closer and closer to 0. And if you remember, the x-axis is an asymptote. If you didn't write this down last time, do it now, because this is a word I expect you to know. X-axis is an asymptote. That asymptote means that as x gets larger and larger, y gets closer and closer to that value, but never ever crosses it. We know it's never going to cross it because when I take a positive number to any exponent, it will never ever ever be negative. There's that one. Okay. So let's look at another function. This is another exponential decay function. I know this because now I have a 3 out here, but the part that is raised to the exponent is 1/2. It's less than 1, greater than 0. So, if you remember from what we've done in the past, that -2 means that it will move down 2 units. So this time, instead of the x-axis being your asymptote, the line y equals -2 will be your asymptote. So we're going to start by drawing the line y equals -2. Now, be sure that you label this, because if you don't, you wind up with all sorts of horizontal and vertical lines, and nobody can tell what any of them are. Make sure you label them. Label your x and y axis, label your asymptote. Now, let's look at our points. X, y. We're going to do x, 0, or -1, 0, and 1. Now, this is going to take a little more work, so I've got 3 times 1/2. Now, when x is -1, that's -1 plus 1, and that's the -2. Well, let's see. When I have -1 plus 1, that's equal to 0. If I have 1/2 to the 0 power, that's 1. So 3 times 1 is 3, so that gives me 3 minus 2, or 1. Okay? Next point. When x equals 0, I have 3 times 1/2 to the 0 plus 1 power minus 2. Okay, this time, look at my exponent first. 0 plus 1 is 1. 1/2 to the 1 power is 1/2. 3 times 1/2 is 3/2. So 3/2 minus 2. Well, 3/2 is 1/2. 1/2 minus 2 is going to be a -1/2. You need to do the extra work to subtract your fractions. Do that on the side. You can do that. Last one, when I have 3 equal to 1, 3 x equal to 1, then I have 3 times 1/2 to the 1 plus 1 power minus 2. I'm getting ahead of myself. 1 plus 1, and that's minus 2. Okay? Now, again, you look at the exponent first. 1 plus 1 is 2. So we're going to do some more steps on this one. I'll work down this way. So I have 3 times 1/2 squared minus 2. So, well, 1 squared is 1. 2 squared is 4. So that gives me 3 times 1/4 minus 2. Now, when I take 3 times 1/4, I get 3/4. So I have 3/4 minus 2. Well, 3/4 less than 2 is going to be 1 1/4, so that's -1 and 1/4. So I have 3 ordered pairs to plot on my graph. So the first one is -1 1. So I'm going to go -1 1. Plot that point. The next one is 0 -1/2. 0 -1/2. And the last one is 1 -1 1/4. 1 -1 1/4. Okay. So again, your exponential decay looks just like the exponential growth functions, except for it's flipped over. Those are problems that I want to have you work on today. Be sure to label your graphs, Show your work carefully. T-table on every one with free values.